Welcome to the lectures on high voltage engineering. In today's lecture, we are going to study Cockcroft voltage doubler circuit. It is also known as Voltage Multiplier, and in some textbook it is also referred to as Cockcroft multiplier. So it is the voltage doubler circuit, and it's find its applications in high voltage engineering. In today's lecture, we are going to study the working of Cockcroft voltage doubler circuit. We will also study what is a single stage circuit, two stage circuit, three stage circuit, and I will try to develop clear understanding among you guys that how this Cockcroft voltage doubler circuit works. Anyhow, these are the names, and what are its applications. It is used to double up DC voltages. I mean, although you have the AC voltage at the input, you have to apply AC power input, but the output voltage is DC. So you have DC voltage at the output side, and whatever will be the AC input voltage, whatever will be the peak value of input AC voltage, it will be doubled up. It cannot only double up, but by using more than one stages of this Cockcroft doubler circuit, which we are going to study, we can double up the generated voltage. So it finds its applications in high voltage engineering for developing the continuous sparks. Okay, so let's first see how we can make the circuit of this Cockcroft voltage circuit. Anyhow, its circuit is very simple, and let's say, so here you have an AC voltage. This is AC power input, and it is also known as the seed voltage. Then there we go a capacitor, let's name it as C1, and then we have a diode, let's name it D1, and then we have another capacitor C2, and then we have a diode, let's name it to D2, and then we have another capacitor which we name it as C2. Now what happens, how the voltage will be doubled up? So this is an AC input, and you know AC input follows the sinusoidal pattern. Okay, so now what happens is that there are two things as well. This is Cockcroft voltage doubler circuit. There are two types. Either it can be a positive multiplier, or it can be a negative multiplier. Now what does it means, the positive multiplier or negative multiplier? So this is a circuit. So this is an input AC voltage. One more thing is referred in most of the textbooks and the literatures, is that it is mentioned in many textbooks, like either it starts with positive half or negative half. What does this means? We will be able to understand these concepts as well. Okay, so let's start. We assume that at the start there is no charge stored on the capacitors. It means that capacitors has no any initial charge stored on them. So let's start with this. Here you have the positive cycle, the positive half. So when the voltage is positive and the voltage is negative here during the first half cycle, this diode is reverse biased, okay, and this capacitor and this diode is forward biased and this capacitor are in series. So what happens if here is the peak voltage, so the voltage here will be Vp by 2 and here it will also be plus minus Vp by 2. But this is not useless because here we are unable to develop the voltage here developed is either half, it is not the twice voltage. So what happens when the second half, or I mean to say when the negative cycle comes in? So when the negative cycle comes in, here you have the positive potential and here you have the negative potential. One more thing to add, here we have the proper earthing, the voltages here are 0 volts. Okay, so when the negative cycle comes in, what happens? This diode D1 is now forward biased and this diode D2 is reverse biased. So what happens? The current flow in this direction, it will charge the capacitor C1 to, the capacitor C1 will be charged to Vp. Whatever the peak voltage is here will be stored here across this capacitor C1. Now what happens? Okay, so now your negative half cycle has appeared. Now what's next? You know that input voltage is sinusoidal and repeats itself. Now when the next positive half comes in, what happens? The potential here is positive and here is the negative for this next positive half cycle. So this voltage, the peak voltage here, will be added up with the voltage here, because you can see here we have positive sign and negative sign and again a negative and positive. So these two voltages will add up. This diode will be reverse biased and this diode will be forward biased, and the voltage here will be, what will be the voltage? These voltages will discharge across this capacitor. So the voltage here will be plus minus 2 Vp. So in this way this capacitor is now charged to the twice of the voltage whatever it is here. Now one more thing. So in this way we have achieved, or we have multiplied the voltage. So it's very simple, isn't? Okay. So now let's say this capacitor is not discharged. I mean this is once charged and we have not connected anything here. Okay, there is an open circuit here. Okay, there is an open circuit. Now what happens? Now when the negative cycle comes in, now when the negative half comes in, what happens? What happens? This capacitor will be charged to Vp, okay, and this diode is reverse bias. And when the next positive cycle comes in, this capacitor is already charged to Vp and here you have Vp voltage. So this diode must be forward biased, but the voltage on capacitor C2 is already which is 2 Vp. So there is no need of any further charge. So whatever be the cycles coming at the input side, the voltage here will retain to 2 Vp. Okay, so this is what we have established here. Let me repeat out everything for your ease of understanding. Here we have an input AC voltage source, the capacitor C1, the diode D1, the diode D2, and another capacitor C2. So what we have seen that when they're at the input side, and initially we assume that these capacitors are having no charge. When the positive half cycle came in, we had no any advantage, because when the input side, when we have a positive input, the voltages across these two capacitors will be Vp by 2 and Vp by 2. So the positive half cycle here is not doing any significant role. What happens when the negative half comes in? What happens? This diode D1 becomes forward bias, and this capacitor is charged to the voltage equal to the source voltage, the peak value, the Vp, in this way. Okay, and so it means that this multiplier circuit has taken its start from the negative cycle, from the negative half. Okay, so we are saying that it has started with the negative half. Okay, so now what's next? Now we have an upcoming positive half. Now what happens? This capacitor is charged, and here you have the positive charge, positive half cycle. Here is the positive potential, and here will be the negative potential. So these two potentials will add up. What they will do? They will forward bias this diode D2, and these voltages will be stored here. This capacitor along with this voltage source will discharge across this capacitor C2, and the voltage here will be plus minus 2 Vp. Now at the end of this cycle, at the end of this half, you have the voltage here 2 Vp, and what is the voltage here? This capacitor is now discharged and has no voltage. So whatever are now the upcoming waveforms, your capacitor is fully charged. It means that this circuit, the Cockcroft voltage multiplier, requires one complete cycle to double the voltage. You see, only one cycle is required to develop the voltage, and now it depends on your input voltage frequency, either it is 50 Hz or 60 Hz or whatever will be the frequency. You will get to know after how much time the voltage will be doubled up. Now what happens if we discharge this capacitor in the form of spark or any other load? What happens? The again cycle will repeat, and since this type of circuit is started from the negative half, okay, and why it is known as the positive multiplier? It is named positive multiplier because here the voltage is positive and here the voltage is negative, irrespective of the source voltage. Okay, so this is what. And one more thing to add here is that the capacitors here, the capacitors C1 and C2 are of equal ratings. Okay, and since here we have only the single stage, so it is known as the one stage voltage doubler circuit. And it started with the negative half of the input waveform, and this is the positive multiplier circuit. Now what we are going to do, we are going to reverse these diodes. Since this diode is in this direction, we are going to reverse this diode in the another direction. Now we will see what happens. Also reversing this diode in this direction. So here we have D2 and the diode D1. Now let's see what happens now to the circuit. So here we go. Here we have just reverse these diodes. Now see what happens. Now when at the input side you are having the positive half, what happens during the positive half? This diode D2 will not conduct, but this diode D1 will conduct. And what will be the charge stored on capacitor C1? It will be plus minus Vp. So during the positive half, capacitor C1 is charged to the peak value of the input voltage. Now when you have the negative half, it means that at the input side the polarities are reversed now during negative half cycle. Now see what happens. This diode D1 is reverse biased, but this diode D2 is forward biased. Since this diode D2 is forward biased, so this voltage Vp will be added up. The voltage in the capacitor, the voltage stored in a capacitor will be added up with the source voltage, and both of them will make a voltage here in this direction, because they will add up and the current will flow in this direction, and the voltage here will be plus minus 2 Vp, twice of the peak voltage, because during this negative half, this capacitor along with the source voltage, this capacitor has discharged into the capacitor C2. So at the end of the negative half, capacitor C2 has twice the peak voltage of the supply voltage, and the capacitor C2 is now discharged, C1 is discharged into C2. So now you see that here this circuit started with the positive half cycle. Okay, so this is what people say cockroach voltage doubler circuit. It started with the positive half. One more thing. Now this is the something which is the negative multiplier, because let's say if these points are marked as point A and point B, if it is the positive multiplier, as we have seen in our previous case, the polarity at the point A was positive and the polarity at point B was negative. But now here this is something different. The polarity at point A is negative and the polarity at point B is positive. One more thing, since this point is grounded or it is earth, so the voltage here is 0 volts. So it means that here you will be having the negative potential and here you will be having the 0 volts. And obviously when there is an excess of electrons, you say this is the negative charge, and here is the deficiency of electrons as compared to the other point, so we'll say this is the positive polarity here. Okay, so this is what this circuit started with, the positive half, and this is the negative cockroach voltage multiplier. Again, this is other things remains the same, and you have seen that it required one complete cycle to double up the voltage. It means that if the frequency is 50 Hertz and your time constant, you know the time constant, then it means that you will get an idea that after how much milliseconds the voltage will be doubled up at the output side. So this is all about the single stage Cockcroft voltage doubler circuit or Cockcroft multiplier. This is also known as the Voltage multiplier. Okay, so now let's start with the multi-stage Cockcroft voltage multiplier doubler circuit. What does it means by multi-stage voltage doubler? Because as you have seen that when you have only one stage or the single stage, we were able to just attain twice of the input voltage, but we want more voltages. So here we will add up more stages in the Cockroach voltage multiplier. Now see how we gonna do this. Okay, so here let's make first, starting from the scratch. This is your AC input, and now you should be well aware with the circuit of the single stage. Here you had a capacitor C1, you had a diode D1, capacitor C1, then here you had a diode D2 and the capacitor C2. This is the single stage, or this is the first stage of Cockroach multiplier. And what is the input voltage? Obviously the input voltage is in the form of repeating sinusoid. It is in the form of repeating sinusoid. Okay, so what happens first, as you are well aware, let's say now catch with me and open up your eyes so that you will be able to understand what's going to happen. So when you have the positive cycle, when the cycle starts, it starts with the positive. Let's say it is starting with the positive half. So here you have the positive half, your diode D1 is reverse biased, and your capacitor C1 is forward biased, diode D2 is forward biased, and capacitor C2 is also forward biased. So what happens? The current flow in this direction. Okay, one more thing. Here the input voltage, the peak value of the AC power is this. This is the peak value of input voltage. So what happens during the first positive half cycle? What happens? The capacitor C1 is charged to Vp by 2 and C2 is charged to Vp by 2, and this is of no use for us. Okay, so what happens when there is the negative cycle? This diode D1 is forward biased and the capacitor C1 is charged to the peak value, and diode D2 is reverse biased. And that is why we said that it starts with this circuit, this specific circuit starts with negative half. And in most of the textbooks they will just ignore this and they will say that your AC voltage is started from the negative half cycle and then you have the positive. Then in that sense we will say that when the polarity here is positive and here the negative, during the negative half the capacitor C1 will charge to Vp. Now what happens when what's next is the positive half. Okay, the polarity here is Vp and the polarity here is positive and here is negative during the positive cycle, during the positive half. So what happens? This capacitor is already charged. This capacitor was pre-charged during the negative half. Now what happens? This input voltage will add up with the voltage stored at the capacitor, and this capacitor will discharge across the capacitor C2 along with this input voltage will also store its energy Vp here, and the voltage here will be plus minus 2 Vp. So at the end of here, at the end of this positive half, the voltage here is developed to 2 Vp, and at the end this capacitor is discharged into this capacitor. So here you have nothing, no energy stored. Okay, at this point, here is the scenario. Now we want to increase the voltage, we want to add more cycles. So here let's see what we have. Here we have another diode named as D3, and here we have another capacitor named as C3, another diode D4, and another capacitor which is C4. Now what happens? At the end of, as I told you, the single stage requires only one cycle to double up the voltage. Now what's going to happen? Now when again the negative half is coming, when the negative half will come, the polarity here will be positive and here will be negative. So when the negative half will come, what happens? This diode D1 is forward biased. So what will be the potential across the C1? It will be Vp. And one more thing will happen. This diode D2 will be reversed bias, okay, during the negative half. Not only this capacitor charges, but this capacitor along with this polarity, minus, plus and minus, plus, they will discharge through diode D3 into the capacitor C4. So the charge here will be plus minus 3 Vp. At the end of this negative half, what has happened? The capacitor C3 is charged to 3 Vp. Capacitor C2 has now been discharged into capacitor C3, and capacitor C1 is having the positive charge. Now what happens? Now when the next positive half comes in, like that, next positive half has comes in, what happens now? During this half, when this capacitor was discharging into this capacitor, this point was acting as the virtual ground. Okay, this point was acting as a virtual ground, because when this capacitor was discharging through diode D3 into the capacitor C3, the current flow was from here to here, and at the same time this capacitor was also charging in this way. So this point was behaving as a virtual ground. Obviously, because here is a low impedance path, so capacitor C1 charged through this. Okay, so now when the positive half has comes in, what happens? Capacitor C1 has Vp charge stored. Capacitor C3 has the potential of 3 Vp. What will happen? They will add up. This will add up with this voltage, and what will happen? Through diode D4, this capacitor along with this, they will discharge where? They will discharge here across C4 and C2. And here you had 2 Vp, sorry. Here you had 2 Vp, because when this capacitor is going to discharge here, then what happened actually? This source was busy in charging this, and through here this capacitor will discharge to 2 Vp, because here you have the virtual ground. So because of this virtual ground, here it will be the 2 Vp. and when at the end of this positive cycle, this Vp, 2 Vp along with this potential and this potential Vp will appear here, and you will get here 4 Vp between these 2 points. Let me repeat what I have done so that you get a clear understanding. Okay, so here we have a 2-stage Cockcroft voltage multiplier circuit. The voltage here is Vp, the peak value of the input voltage is Vp, and here we have the AC input voltage and here we have 2 stages. This capacitor C1, diode D1, diode D2 and capacitor C2, they are associated with the first stage, and the second stage is represented with the blue color. Okay, so what happens, let's say it starts with the, it starts with the negative half cycle. When you have the negative half cycle, this diode D1 will charge, this diode D1 will be forward biased and D2 will be reverse biased. So capacitor C1 will be charged with the voltage Vp. Now what happens here? Now it comes the positive half. When the positive half comes, this voltage will add up with this voltage across this capacitor, and they both will discharge here, and the capacitor C2 will get the charge of plus minus 2 Vp. And now what happens next? Now again the negative half comes in. Now when the negative half comes in, since this capacitor was discharged into this capacitor C2 before, again this diode D1 will conduct and the capacitor C1 will be charged with the Vp, as well as since here is the positive potential, and this capacitor C2 and this diode D3, they will behave as the forward bias. Since the current is already flowing in this direction and there is another path of the current such that this capacitor C2 will discharge across this capacitor C3, making the voltage here plus minus 2 Vp. So now at the end, this point is behaving as a virtual ground, because here the current is already flowing, and when the diode is forward biased, so this point is obviously the virtual ground. Here obviously you have the ground. So now what happens during the next positive half? What happens? Here we have the potential Vp and here you have the potential 2 Vp, and this capacitor was discharged into C3 before. So what will happen? This voltage source will add up with the voltage here, and the total voltage here is 4 Vp, and that will be discharged across these 2 capacitors. So the potential here will be 4 Vp. So in this way, using 2 stages, you have what you have done, you have doubled up the voltage, or like the equation we will have be like this. The output equation is like 2 NVP. So when you have only the single stage, the output will be 2 Vp, and when n is equal to 2, that is you have 2 stages, the output will be 4 Vp. Now what we are going to do, we add up another stage, n will be equal to 3, so our output voltage will be 6 Vp. What we have to do, if you want to add another stage, just do this. Simply add up another diode named as D5, add up a capacitor here named as C5, add up a diode here D6, and add up a capacitor here C6. So now this is the 3-stage Cockcroft voltage doubler circuit. Okay, and the output here will be, now what happens, let's say here you have the charge storage for Vp. So what happens, what comes next, when you have a negative cycle, this capacitor C1 will charge to Vp, and this 4 Vp will be stored here, will be discharged to C5 through diode D5. So here you have 4 Vp, and during the positive half what happens, this voltage adding up the potential here with here and here, you will get plus minus 6 Vp across these 3 capacitors. So more you add these stages, the more you increasing the n, the more the output voltage you are increasing. One thing to add here, one thing important to note for such type of circuits is that we cannot apply continuous load. You cannot apply a continuous load here. This circuits, such type of circuits can only be used for continuous arcing or continuous discharges. If you have 3 stages, it will require 3 cycles to make voltage to 6 Vp. Okay, so this is all with the Cockcroft voltage doubler circuit. Here you have 3 stages. We have also discussed the single stage, and in this way we can double up the voltage. But remember one thing, the input must be AC power source and the output is in the form of DC, and obviously you have this circuit is used for the continuous sparking. So this is all about our today's lecture. Thank you.